All right, welcome back, everybody. Today, what I want to do is I want to talk about SOH. Now, we're just going to do today, and we're going to kind of go over this stuff from a very much of a review perspective. You have already talked about right triangle trig when you were in geometry, so this should absolutely be something that's review for you. But as always, if you're struggling with this at all, please make sure you are reaching out so that we can get you the support you need. Our objective today is that you're going to be able to determine the missing lengths using SOH. So, coming over here, we have a right triangle. Now, SOH only works when you are working with a right triangle. In this particular situation, we are missing a side length over here. So, the way we would use SOH or right triangle trig is we would first look to identify any angles that we have in the triangle. Now, when we do this, we're never allowed to use the 90-degree angle. So that will never be the angle that we're allowed to use. But in this particular situation, we do know that this angle is 52. Now, what you want to do at this point is identify the side right across from it as the opposite. Obviously, you want to identify where the hypotenuse is. That's the side across from the right angle, the longest side. And then whatever's left is your adjacent side. Now, in this situation, I don't know anything about the hypotenuse, so the hypotenuse is not going to be helpful to me. What I do know is I know about the opposite side, and I want to find the adjacent side. So if I just go up to the SOH, notice how opposite and adjacent both show up in the TOA, or the tangent part of that mnemonic. So we want to actually use tangent for this. So what we would do is we would say the tangent of our angle, 52, is going to be equal to the opposite, which is 12, over the adjacent, which is x. Now, once we get this far, we want to actually just solve this. Now, essentially, one thing to remember is that this is just a number. When you punch this in on your calculator, that's just going to give you a number. We're not going to do it just yet, but it's important to remember that that all moves together as a number would. So first what we want to do is let's get the x out of the denominator there. So we're going to multiply both sides by x. That's going to cancel these two out, and I would be left with x times the tangent of 52 degrees being equal to 12. Now, I do also want to get x alone here, so I can come over here and now divide off the tangent of 52 degrees. And when I do that, these two pieces cancel each other off, and I'm just left with x is equal to 12 divided by the tangent of 52. Now, in order for us to evaluate that, we got to set our calculator up if it's not already. Your calculator does switch from time to time, so it's always important to check this before you do any right triangle trig. To check this, what you need to do is put your calculator into degree mode. So you want to hit the mode button if it's a TI graphing calculator. And then you want to sit there and look for where it says angle. I can see mine saying angle kind of right over here. So right next to there's angle. Your calculator's default is to have it in radians, so you really want to make sure that you put it into degree mode. If it's not in degree mode, you're going to get different answers from us. So this first one's really important for you to check. So coming over here, I want to punch this in now. I'm going to say 12 divided by the tangent. You can see that button right above the right parenthesis, and now I need to enter in my angle. And when I do that, I find out that x is equal to 9 point, let's just call it 38 at this point. And really that answer should always make sense to us. Now 52 is obviously bigger, so hold on. We can do a little bit more math on this. So let's just go at this from a common sense. We know all triangles have 180 degrees. So in our triangle, we can already see a 90 degree and that 52 degree, which means this side is 38 degrees. Now, one thing we do know about triangles is that if you look at the side across from them, the bigger the angle, the bigger the side is going to be. That is why across from our 90-degree angle is always our hypotenuse, which is our largest side. So 52 opens up to a side that should be bigger than what 38 opens up to. We just figured out that x in this problem should be 9.38, which is smaller than 12, which makes sense for our purposes here. Let's look at another problem. So here's another problem. In this situation, we are given this angle. So across from this angle is going to be our opposite side. Of course, here is your right angle, which makes x your hypotenuse. We don't know anything about our adjacent, so I don't need to worry about it. So which one of my trig functions talks about the opposite and the hypotenuse? Well, that is sine, because I can see the opposite and the hypotenuse. It's the only one they're both located in. So I want to take the sine of the angle I'm given, which is 20 degrees. That's going to be equal to 10 over x. Now to solve this, just like we did on the last one, we're going to start by multiplying both sides by x. That's going to make these two cancel. It's going to leave me with x times the sine of 20 degrees is equal to 10. Now to get x alone, let's divide off the sine of 20 degrees. These two cancel each other off. We're going to be left with x equals. So solving this now is when we grab our calculator. We should get a side. Now just thinking about this for a second, we're solving for the hypotenuse, so we should definitely get a number that's bigger than 10. So 10 divided by the sine of 20 degrees, no plus, I want to enter, is 29.24. Which, as far as I'm concerned, makes perfect sense for this. 20 degrees is a small angle. It opens up to 10. So the side across from my largest angle could definitely be significantly larger than that. Now let's use trig to actually find a missing angle. So in this situation, we are missing the angles for x and for y. So what you want to do right off the bat is you simply just want to pick one of the angles to work with. I think I'm going to choose to work with angle x. Now, using angle x, you want to denote the sides. So across from this would be its opposite side. We don't know anything about the opposite side, so I'm not even going to label it. But that does mean that this is my adjacent side, and obviously across from the right angle is always your hypotenuse. Now, since we don't know what x is here, that's what we're going to be looking to find. We do know the adjacent side and the hypotenuse, which should make us start thinking already that we are working with a cosine problem, because the adjacent and the hypotenuse are talked about in there. So if I were to look at the cosine of my angle, now I don't know my angle, so I'm going to put x this time. So the cosine of my missing angle should be equal to my adjacent, which is 31, divided by my hypotenuse, which is 41. So now in this situation, when you want to find the angle that is missing, x, in this situation, what you need to do is you need to use cosine inverse. So you're going to do cosine inverse. That is the second function on the cosine button. It should look like cosine with a little -1. And you are going to simply trade spots here. So inside the parentheses, you're going to put 31 over 41. And that's going to be equal to the angle. Whenever you're looking at cosine angle or cosine inverse, you're finding an angle measure. So if you look at the cosine inverse, so I'm going to do second cosine, there's my cosine inverse of 31 over 41. That's going to tell me the measure of my angle. So we're going to find out x is equal to 40 let's just call it 88 degrees. Now, with a right triangle, right, so this is 40.88 degrees, we do know that this angle plus this angle plus this angle all need to add up to be 180 degrees. So if I were to solve for that missing angle, I would know that this angle has to be 49.12, approximately. We did round that other one. Now what I'm going to do is I'm going to just disregard this for a second. So I'm going to take this number, I'm going to throw it to the outside here, and let's actually use trig to find that angle to verify this works, and then it gives us an additional chance to practice it. So to do this, what we do is we basically start over. So get rid of everything we know so far. If I wanted to find angle y, the side across from it would be the opposite side, and this is still going to be the hypotenuse. So if I was trying to find angle y using trig, I could do the sine, since that is the opposite over the hypotenuse, of my angle is equal to 31 over 41. Now, since I am looking for the angle, I want to use sine inverse. and I'm going to simply switch and put the fraction inside and y on the outside. So doing that, I'm going to end up with my 31 over 41 here is equal to y. So punching that in, second sine 31 divided by 41, and we find out that y ends up being equal to 49.12, which is in fact exactly what we said it should be, right? So we use trig kind of from both sides to pinch in and figure out what those angles are. Officially, if you were to get a problem like this and you already figured out what angle x was, then I would say you would be fine to use the fact that you know there's 180 degrees in a triangle to get the missing side. Let's do two last problems quick. In this first one, we are being asked to find what x is. Now, we also are being asked to find what theta is in this situation. So let's first start with theta. So if I wanted to find theta, this was my angle, then across from it, this would be my opposite side, this would be my adjacent side, and this would be my hypotenuse. So since I know my adjacent and my hypotenuse, if I were to introduce my opposite side, I would have multiple variables in the problem and I wouldn't be able to solve. But since I know the adjacent and the hypotenuse, I'm going to use cosine. So I'm going to say cosine of angle theta, that's my missing angle that I'm looking to find. That's going to be equal to the adjacent, which is 4, over the hypotenuse, which is 8. Now, since I'm looking for the angle, I need to use cosine inverse, and I'm going to flip and put the fraction in the parentheses and move theta to the outside. So when I evaluate second cosine of 4 over 8, I find out that theta is equal to 60 degrees. Now, what that means about theta is that if this is 60 degrees, we actually have a lot of options we can consider here to figure out the missing side. So if this is 60 degrees, then we also do know we're working in a 30, 60, 90 triangle, so we could use special right triangle to figure this out. Remember, if you wanted to go that approach, you know that the long leg is always equal to the short leg times the square root of 3, so this should be 4 square roots of 3. So that would be one way you could solve for this. Another way you could solve for this is by using the Pythagorean theorem. So if I wanted to do the Pythagorean theorem, I'd say 4 squared plus x squared is equal to 8 squared. 8 squared is, of course, 64. This is 16 plus x squared. 64 take away 16 is equal to 48. So I get x squared is equal to 48. So this, we would square root, x equals the square root of 48, which we could then break down. So breaking down 48, this would be 2 and 24, which would be 2 and 12, which would be 2 and 6, which would be 2 and 3. So I can pull out two 2's, so I'm going to be able to pull out a 4. 2 times 2 is 4, and I'm still left with the square root of 3. So we just found this answer two different ways. The third way you could actually find this answer is by using trig. So once you know that this angle up top is 60, then you know, of course, that this would be the opposite side, this would be the hypotenuse, and this would be the adjacent. You can use any trig function here really to solve this. So for example, I'm going to use tangent since I know the adjacent and I want to find the opposite. I just need to use a trig function that talks about the opposite. So if I wanted to go at it that way, this would be a third way. You don't need to do it 3, you just need to have 1. I would say that the tangent of my angle, which was 60, that's the one we found, would be equal to, tangent is the opposite over the adjacent, so this would be x over 4. So to solve this, I'm just trying to get x alone, I would say, let's multiply both sides by 4. So I'm going to be left with x is equal to 4 times the tangent of 60 degrees, and then we can just evaluate this. 4 times second tangent. Oh, not second tangent, just tangent. I'm sorry. I got something going on. 4 times tangent of 60 gives us 6.92. Now, if I just take 4 second square root 3, I do find out that I get exactly on that same number, right? So lots and lots and lots to consider here. I'm going to get rid of some of this extra work. Let's do this last problem. So here we go. We are given the angle here. We're being asked to find the missing side length. So the missing side length, this is my opposite side, and this is my hypotenuse. If I wanted to solve this, what talks about the opposite in the hypotenuse? Well, that's of course sine. So sine of the angle, which is 32, is equal to my opposite, x, over my hypotenuse, which is 18. Now, in this situation, to get x alone, we're going to start by multiplying both sides by 18. So I'm going to get 18 times the sine of 32 is equal to x. We don't need to do any additional work here because x is already alone, so 18 times the sine of 32 degrees is equal to 9.53, or let's just call it 54 when we round up there. That's it, ladies and gentlemen. That is what you need to know and what you need to remember. Remember, a lot of this was already taught to you in geometry, so if you're struggling with this, please make sure you are reaching out and asking for help. Thank you so much for watching. Have a great day.